this video, we are going to learn about stack. So first of all, let's see what is stack. So stack is a sequence of items that are accessible at only one end of the sequence. So stack is a sequence of items that are accessible at only one end of the sequence. So let's take an example. Suppose this is our stack. So in this stack you can see one end is closed and one end is open. So all the operations will be performed through this open end. This end will not be used for any operation. So for example, if you want to add one of the element, so that element will be added from this end and will be added over here. For example, we are going to add element 10. So that will be added over here. Now if you again add another element, that element will be added from this end and it will be added over here. For example, we are going to add 20. This way you can add elements from the one end. So elements also will be removed from the same end. So this end will not be used for any operation, that means for adding or removing, this end will not be used. Only this end will be used. So this type of structure is known as a stack. Here if you want to remove any element, for example now we want to remove element. So from the top we can remove this element. So this element will be removed and now at top this element will be there. To denote which element is at the top, we can take one extra variable, that is top. This variable will use to mention the index of the top element. So at initial stage we will assign this index as a -1. That means now it is not pointing to anyone. But once we add any element into the stack, for example we add element into the stack, so this top will be increased and now top will point to this element. So this is our top element. That means this element refers the top part. Now if we add any element, so here for example we have added 20 element, so this top will be increased and now this element will be referred by the top. So likewise removed. Now for example if we are going to remove this element, if we remove 30, so now this top will be decreased and now this one will become top. This will be removed. So now this element is a top element. So once we add element, top will be increased. Once we remove element, top will be decreased. So this type of structure is known as a stack. So stack has limitation that you can add or remove element from only one end. Another end will not be used for that one. Now let's see what are the different types of operations available on stack. So types of operation on stack. So few of the operations, first one we can say we can create a stack. So that is one of the operation, create. Then insert into the stack, that is known as a push. Push operation is not as known as a insert into the stack. Next one, delete. This delete operation is known as a pop. Next one, search element into the stack. Next one, traverse, or we can say display element of the stack. Next one is empty, whether stack is empty or not. Then is full, whether stack is full or not. So these are the different operations available on stack. So we can perform this all operation onto the stack. Now let's see few of the operations on the stack. For example, we are going to learn push operation. These are the core operations on the stack. So push and pop, these two are the main operation on the stack. Push operation, that means insert element into the stack. So for example, this is our stack, and at initial top will point to the -1. So once we add any element, for example, we are going to add any element 10. So this top will be increased and this top will point to this element. That means top is now become 0. In next step, if we add any element, for example, we are going to add element 20. So this top will be increased and top will become 1. So this way top will be increased once we add the element into the stack. So for this one, if we write the algorithm, so let's see algorithm for this process. In algorithm, first of all you have to check whether your stack is full or not. For example, this stack has maximum capacity of 4 elements, and if you reach at the top position, then you cannot add more element into the stack. So first of all you need to check whether your stack is full or not. So how you can check whether it is full or not? Here you can see, for example, there is the capacity of stack is, for example, max is equal to 4. In this example it is 4. What will be the value of top when this stack is full? So at that time you can see 0, 1, 2 and 3 here. Once it is a 3, that means max minus 1. So if you reach over here, that means value of the top is 3, at that time your stack is full. So you cannot add more element into the stack. So you can write down those steps over here. Check if stack is full. That means if top is equal to max minus 1. That means we are at the top of the stack. So stack, you can write stack full. Stack full and return. Else, if stack is not full, then what we need to do? First of all, you need to increase the index of the top element. So what you need to do? You need to do top plus plus and we can add element at the top position. So here we can write down stack of top is equal to our newly added value. New value we can add here, and this is the end if. So this is the algorithm for adding element into the stack. That means this algorithm is a push algorithm. This algorithm is for push operation on stack. So in this one you can see first of all we need to check whether stack is full or not. Once it is full, we cannot add, we just need to return. And if it is not full, we can increase the value of the index and we can add that value at new positions index, and this will be added at the top of the stack. Now let's see the another operation of the stack, that is pop. So in pop, what happened? For example, this is our stack that has the capacity of 4 element. For example, 1, 2, 3 and 4. Total 4 element we can add into the stack. So for example, we are having already added few elements like 10, 30 and 20 element into the stack, and this is our top element. Now if we remove element from the stack, so the top element will be removed. That means this 20 will be removed. Once it is removed, that means this top will be decreased and top will locate to this element. So what we need to do that pop operation, we need to just decrease the value of the top. If we write down the algorithm for this one, then first of all we need to check whether stack is empty or not. If stack is empty, that means top is equal to -1. Then we can say there is no element into the stack and we can write stack underflow. So this condition we need to check. So first of all we are checking if top is equal to -1. That means what? That means write stack is empty, right? And we can return from this algorithm. Else what we can do, we can remove the we can decrease the value of top by 1. We can write down top minus minus. So this is the algorithm for removing element from the stack. We can check the condition that if top is equal to -1, that means stack is empty, and if it is empty we are returning our program from here. Else what we are doing, we are just decreasing value of the top. Now in this case, if we want to know that which element we are going to remove, so before decreasing this value you can write down the statement over here. For example, x is equal to stack of top. That means whatever element at the top position, that will be stored into x, and after that one decrease the value of top and return the x. So here whatever value we are storing into this x, that we are going to return over here. That means the deleted element we are going to return, and here we are going to end the if condition. So this is the algorithm for pop. That means if we want to remove element from the stack, this is the algorithm for that one. Applications of stack, where stack can be used. So stack can be used for conversion, it can be used for function call, it can be used for the Tower of Hanoi application, Tower of Hanoi, memory management, or for backtracking, and many more applications. So these are the applications of stack.